Multiplying a matrix by a constant is called scalar multiplication, and it's a pretty straightforward process. Let's take a look at two matrices to try it out. The first one asks us to do 4 times matrix A. I'm just going to rewrite it as 4 times the matrix that has a first row of 7, 1, and a second row of negative 9, 0. All we simply have to do is just distribute that 4 to each entry in the matrix. So the entry in our first row, first column is going to be 4 times 7, which is 28. The entry in our first row, second column is going to be 4 times 1, which is 4. The entry in our second row, first column is going to be 4 times negative 9, which is negative 36. And the entry in our second row, second column is going to be 4 times 0, which is 0. As you can see, the dimensions of the matrix don't change. I started out with a 2 by 2 matrix. Matrix A has 2 rows and 2 columns. I simply multiplied every entry in the matrix by 4, and my result was still a 2 by 2 matrix. Now let's do the same thing with a matrix with different dimensions. Matrix B is a 2 by 3 matrix. 2 rows and 1, 2, 3 columns. I'm going to do the same process. This time I decided we should try to multiply this matrix by a negative number. So let's do negative 6 times the matrix with first row 4, 8, negative 1, and second row 0, 11, negative 3. Again, I'm just going to distribute the negative 6 to each entry in my matrix. So the entry in the first row, first column, is going to be negative 6 times 4, or negative 24. The entry in the first row, second column, negative 6 times 8, is negative 48. The entry in the first row, third column, negative 6 times negative 1, is 6. The entry in the second row, first column, negative 6 times 0 is 0. The entry in the second row, second column, is negative 6 times 11, which is negative 66. And then finally, the entry in the second row, third column, is negative 6 times negative 3, which is 18. So that's an example of scalar multiplication.